let's see how do we use this information. What is important of this information, which we consider very critical for the whole precision agriculture process. Well, this is a definition from a research institution, the INTA. It's yield map information. It's, well, this is the obvious, but we need to remind us. It's an essential tool for precision agriculture. We can visualize, we can quantify the spatial variability of crop yields at the field production scale. So that's the basic concept. It's how we use it. It's really key to understand the variability and to measure, to quantify the results. So the first thing is to recognize the spatial variability. So we can see very clearly defined zones in this example. It allows to quantify the yields in each of those zones, what the actual yield was achieved. And this is helpful for then doing nutrient removal calculations, management decisions, and what potential we want to reach. Then something very important that we'll see in the next slides is operation auditing. If the operation was done correctly, if the speed was adequate, because we have seen in several cases that going above certain speed, and this also has been the subject of research, if you go above certain speed, you have yield losses, and this can be very important, and this can really take away the profits from the whole operation. You can do more sophisticated or more in-depth analysis in between seasons and the variations between years. So you can see areas with highs that are very stable, areas that are unstable, areas that have consistent low yields, consistent high yields. Also, it's very important to do field strips evaluation. So if you're going to do some field tests, it's key to have a well realized yield operation along the test strip, so you can really test what happened in that field. And of course, it completes the precision farming cycle, and we'll see this in a moment how it's really, we understand it as a cycle, and this is the last part of the cycle, which gives us feedback on everything we did during the season. So going into a little bit into detail into these concepts, recognizing spatial variability. Of course, we have the productivity map, which is the summary of many years of crop behavior based on the NDVI index. Based on that, we can create management zones maps. And when we do the yield map, when we generate the yield map, so we can see how those management zones performed. So really, it completes the whole cycle. Now, something to consider is that there's some disadvantages of recognizing variability based on a single year. We need to have more than 1 year. So that's why we use more than 1 year of image of a remote sensing based image. The map may have calibration errors. That's one thing. The map can have errors due to operations issues, such as high speed. Also, 1 year's yield can differ from the average due to pests and diseases, climate varieties, and management. So in this case, in the case in the left, in the case in the right, we see that in this case, the yields variation, we have the yield map in the middle, we have the speed map in the right. The yields variation were due to the speed and not to the productivity zones. So we see that in areas with high speeds in red, the yields were lower. So this is not a reliable map to create a management zone. So a single yield map may not be reliable. If we see 2 or more and showing similar behavior, then we can determine management zones. So that's something important to keep in mind. Also, it allows us to quantify the yields in each management zone. So if we are using productivity maps based on remote sensing to create to see the areas with consistent high yields and areas in green with low yields, we can then use the yield maps to quantify how much was actually the high or how much was actually the low. So when you use Farm 360, or if you use your own software, you can do a cross analysis in Farm 360 automatically You can do a cross analysis of what was the yield in each management zone, and you can see, okay, the high yielding management zones were in the 5.5 level, and the low yielding were in the 3 tons per hectare level. So that gives you very important information to quantify the yields and make management decisions. So this is when we use a productivity map to determine management zones, and in this case it's due to topography and salinity. So you have here a light blue, it's saline, in green it's low, then we have medium hill, and we have hills and the red spots. So this is very related with topography. You can see what were the yields in each management zones, in each zone that we have characterized. So the saline soil, it was in the 3.9. In the lows, it was the highest in almost 5.4. In the hills, it was lower. So this will vary in a wet or dry year, and also depending that. So this can guide your decision. You have numbers to see, okay, how much was the yield in the low area, if it's going to be a wet year or a dry year. That will have an influence in your fertilizing decisions afterward. Something very, very important, it's the operations auditing. We have control over the operation. So we see several cases when we process yield data and we have the yields map and the speed map where we see the yields is related with the speed because when the harvester was going too fast, then we had a drop in the yields. And also we have the productivity map to compare, and since we can have measurement of what was the yields in a high productivity zone, we can do an estimation of losses. So in this case, it was about 1 tons of soybean due to a speed increase of 3 kilometers per hour. So what this gives you, it's two things. This is something that if you process as you are doing the harvesting operation, this could be very important to avoid future losses. So you can show this to the harvester operator and make sure that he goes below certain speed. Or if it's too late, then we can make decisions for next year and be very careful about this aspect. Again, this is another example that we see the speed. So measure the speed is very, very important. And in this case, it was measured that a 205 kilograms less yield in wheat because there was a 2.6 kilometers per hour harvest speed increase. Again, this to analyze our management decisions. In this case, we have a low productivity based on the productivity map. This was done by macro. So there was no variable rate applicator, but actually there was a division in 2 zones. So we made this agronomist made a decision on how to manage the low and the high yielding zone in 2 areas only. So in the low yielding areas, we had a deficiency in sulfates. The high productivity had a deficiency in phosphate. So he defined a certain prescription for the low productivity areas, for the high productivity areas, and what the yield map gave us is the opportunity to measure what were the results of that decision. So he was able to measure, and almost the low and the yields were equal in this year, in the 5.8, 5.7 range, and he could verify a 20% increase in performance. Otherwise, it would have been very difficult to measure what was the economic result of his decision and inform the farmer, okay, this is what we invested, and this is what we got in return. Again, that was for a fixed rate. This was for a variable rate. So again, the cycle is to do the productivity map, analyze the variability, then we make the decision of the different fertilizer rates that we're going to apply for the high, medium, or low productivity zones. So it was about, I don't know, it's too small, but it's about 154, and I don't see what was the actual fertilizer. But the important thing is that by having the yield map, we can do an analysis by zone and say, okay, how much was invested in um, in the different zones, and by measuring the yield 3.8, 3.5, and 3 tons per hectare, and having the cost invested in each zone, we can have what was the difference against doing a variable rates. A single fixed rate application. So in this case, it was a difference of $111 per hectare in the low and medium areas, because we invested less, and the profit margin was higher. Okay, we can also evaluate yields in different seasons for different types of crops, and this as in this example. Maybe again, we can see that the yields can perform differently from different types of crops. We have soybean, barley, sunflower. Um, so we see that barley, we can see that in the high productivity zones, it will have a higher performance, where that relationship is not so clear in soybean, uh, and we can quantify that relationship. Again, in rye, we have this different performance in different productivity zones, but in soybeans, more or less even. So it's very important to measure what is the yields by zone. Again, data analysis, we can have different varieties, and we can see how those varieties perform in different management zones. Evaluating corn hybrids, it's also very important. We have here different strips with hybrids, and we can, this is a key for field strips analysis. So we can have the performance, the average performance of each hybrid. And again, we can have hybrids by management zone, what's the yield level. So in summary, we strongly believe in this cycle, where it's an integrated approach, where we are going to think in terms of management zones, starting with the productivity map. We can have different protocols in order to make definitions of what is going to be applied in different zones. Based on that, we can do variable rate prescriptions. Based on that, we can also do the application reports. And finally, the yield map, it's the key to help us measure the results of what we have done, as we have seen in the previous slide. So it's really a key piece of information to measure the performance, to quantify what were the yields according to different decisions, and to make decisions forward and make the whole farming operation more profitable. And of course, the second aspect is to be able to control the quality of the operations, and make sure that that we're doing things right, and that we're not having yield losses due to a poor operation.